Okay. Others also please be interactive so that we can make an interactive session that is more benefited to you guys itself, not for me. So make sure that when anything is asked to you, please respond. So as Pawan said, we have discussed like what is the evolution of UVM, and we have also discussed what is the difference between the traditional Verilog or SystemVerilog test bench and the UVM test bench, and why most of the people or in the industry, they have moved to the UVM adoption, why they are adopting the UVM as their verification methodology. So what is it making more interesting to choose UVM? So what are the different features of UVM we have discussed? And as I said, we have discussed also about some keywords which we use regularly. And we have also discussed what are the limitations of the system Verilog and Verilog which we had before, and that's why which are things that are newly added features in UVM, how they resolve which are not there in the system Verilog and Verilog. So HVL means hardware verification languages, right? So all those we have gone through, and we have also okay, and we have also gone through like how exactly in the UVM test bench, what is the hierarchy we have, what are the different components we have, just like an overview we have gone through, right? We haven't understood entirely, but we understood there is something like static component, which is module, which is supporting our class-based test bench. Like how we have saw a small snippet of its code where we have a class, which is a dynamic component, which is not standalone. We have created a module where inside that we have instantiated the class, and we have created the object of it, and then we are, if any properties of the class we want to use them, so those things we are trying to do through the module. So this is all what we have gone through so far, right? Is there anything I have missed out? So I think mostly everyone has joined. So do anyone have any queries from the last session? Okay, fine. Then let's quickly move to the next part. So we have yesterday discussed, right, like how the UVM test bench hierarchy looks. But we also have to discuss something related to the different, what is the UVM test bench architecture, and what are the different components in the UVM test bench architecture, and each component is responsible for what of its functionality in the UVM test bench architecture. So each component plays a key role to build a entire UVM architecture. So that's why we will go through each component today in detail and what are its functionality and so forth. Okay. So here this is like a basic overview, like basic hierarchy. We have like tests inside that EMB. Inside that we have agents. Two agents we have. So can anyone tell me in the test bench how many agents we can have? Is it like only two agents we can have, or only one agent we can have?
I think it's based on our requirement, right?
Yeah. So how many we can have?
Like, okay. I think for if you have like one IP, we can consider one agent. If you have multiple IPs, you can go for multiple agents.
Correct. So n number of agents is possible to have it, right? So that's the main thing.
Yes, like I have one more question here. So
Yeah.
you mentioned one agent contains one driver, monitor, sequencer, right?
Yeah.
So is it possible to, to use multiple drivers and sequencer in one agent?
No. In one agent, you will be having only one driver and one sequencer. If there is a other functionality that you want to perform, then you can use something like UVM factory override, and you can replace that particular driver with the other driver which you want. But at once, only one agent will be having one driver.
Okay, got it.
Yeah. So now let's move to the next thing. I feel everyone is on the track. Okay, so this is the main UVM test bench architecture. So here, yesterday we have already discussed, right? We will be having some test bench top, like which will be a module. Inside that, we will be having a test. Inside that, we'll be having an environment. So inside environment, we'll be having this agent, what we have saw, right, just now. In that agent, we'll be having three components. One is a driver, monitor, and the sequencer. So, and then we have something called interface, and DUT is nothing but, can anyone tell what is DUT? Yesterday we had discussed, right?
design in the test.
Yes. The thing which we are trying to verify is the DUT, right? So that is the design under test. So can anyone say what is this between the DUT and the driver?
Interface.
Yeah, interface. So we know that there are different connections here, right? Like this. So these connections are nothing but like how in the SystemVerilog we have the mailbox. In the same way, we have something called here in the TLM modeling. It's a transaction level modeling where you will be having different TLM ports, exports, implementation ports, analysis ports, so on. So for now, just ignore the things like related to the TLM ports and all. Why is it connected in the this rhombus shape? Why is it connected in the circle shape? Just ignore all those. We will discuss it in our further sessions. So for now, today you can concentrate on the different components in the UVM test bench, right? So here we have something like monitor, driver, sequencer. If you see here, we also have a sequence. Okay, and the sequence from the sequence only it will go to the driver. The sequencer is in between these two, which will route the sequence items, whatever we get, the transaction which is coming into the sequence items, that will be transferred to the driver, means to the sequencer. The sequencer will route in between from the sequence to the driver. Okay, and the driver will send the data to the DUT as an output, and the DUT will again give its output. Who is this? Keep on. The driver will send the input to the DUT and the DUT will provide the output to the monitor. So the monitor will capture the data and that it will send to the scoreboard. Okay. So this is how it works. So this is the UVM Testbench Architecture. This is the basic UVM Testbench Architecture. We will go through the different components which we have. Like what exactly each component does. So you can have different kinds of agents as well. Means the agent can be passive also, active also. If the active agent means all these things will be there. Driver will be there, monitor will be there, sequence will be there. If the agent is passive, for suppose, then only monitor will be there. Okay. So we will go through each of the things.
So why is it so that if monitor is there, then it will be passive?
See, the requirement will be there. First, I will tell you like why it is so. Only monitor is there. We have two kinds of agents, and for some requirements, we need all the things like driver, monitor, and sequencer. There are some requirements where you don't need the driver and sequencer at all. Only monitor is enough. In that case, why do we need to have the extra things to be created? It's not necessary, right? It is just wastage. So that's why for those things you can have an passive agent. So where the requirement is both driving also and collecting also, then we have to ignore. We don't need to have the active agent. We can only just take the passive agent. That's why.
Okay.
I will tell you what is the exact requirement also, like where exactly we can use this. Okay.
Yeah. Also,
So now,
can you scroll back to the previous slide?
Yeah. Yes.
Yeah. So yes, here in the sequencer we are seeing sequence item and sequence, right?
Yes.
So
Yes.
basically, sequencer will send exactly what, like sequence items or sequence?
Sequences will generate sequence items. The sequence items will is the basically which the sequencer will route to the driver. Basically, the transaction.
Okay, so sequencer will send the sequence items to the driver.
Yes. Yes.
In that case, sequence is also an object, right?
Yeah, sequence is an object only. See,
sorry, component, right?
No, sequence is not a component. Sequence is an object that will be not in this hierarchy. The component hierarchy will be having only test, ENV, scoreboard, agent, monitor, driver. Sequencer is also a component. But the sequence which is there, no, that is out of the hierarchy. It will be there in the object. It won't be a part of the component hierarchy. the test bench hierarchy. Okay, so that's why the sequence items, if you see, it has been just highlighted like this. No, it means we are trying to say that this is not part of the component. Only the sequencer is part of the component, which will collect from the sequence and it will provide it to the driver. That's why we say, right, the component means they will be there for the entire simulation, but the sequences will not be there for the entire simulation. So that's why they are categorized as a UVM object. So we will discuss all those further. If still you don't get it, we will again discuss. Okay.
Okay.
Yeah. So now here what we are trying to say is the UVM test bench has different verification components, as we have already seen. Each component has its own responsibilities to be done in the UVM test bench. So the architecture, here it is a basic architecture. We have the driver, monitor, sequencer. Inside the environment, we can also, here we had a scoreboard also. So we can have something like coverage collectors also. So which is we can also have some reference module. Reference module means we can have a logic which is there in the DUT. No, the same thing you can mimic and put that part of the code in the reference model, and that can be through the day. So the output of the reference model into the scoreboard and the monitor what we get, both it will compare. So that also like the reference model logic can be included inside the scoreboard itself. But still, if there is something very complex, in that case, you can have a reference model block. Inside the reference model, you can have the mimic logic of the RTL. Okay, so these are the different components that can be present in the UVM test bench. So that is what is the entire the summary of all this. Okay. So now we will see what exactly the driver is, what exactly the data item is, so all those things. So if you see first, the thing is the data item means that is nothing but the transaction class. So whatever things like, for example, any of the protocol, in that protocol, whatever inputs are there, whatever different feeds, whatever outputs are there, all those things we will first list out, right? After listing out, what we can start with is the transaction class. In this transaction class, you can put all those different inputs as each property, and you can continue further. You can add some things, and then again you can go through some of the things. If you feel something is missing, again you can add those everything. So basically, the transaction class will comprise of different inputs which are there in that particular spec, and even the outputs. So it is now, if you want to, as we have already discussed yesterday, the constraint random test bench, right? It means all the input fields are randomized so that if you can cover the maximum things. If suppose one of the right address is there, if you just write bit address, so at once you can have only one address, right? Or you should be able to giving some address as a hard-coded value, right? So that instead of doing that, we can just randomize it so that, and you can control that randomization in your own way using some constraints. So we'll also look at some code also today so that it won't be very tough for us to imagine like how transaction class looks and all. So basically what they're trying to say is in the data items, we have the bus transactions and the instructions. For example, the instructions in the sense basically any constraints if you want to put or anything which is related to that protocol, you can put in the particular transaction class. If there is some, if I have a requirement that the right address which or the address which I have, it should range from only 0 to 10. So I can write the address should be ranging between 0 to 10. So using some constraint, I can use like constraint and keyword and the constraint name. And then I can write like particular address should be inside this range. Like that we can give. So this is depending on us how intelligently we randomize the data and how well you will write the constraints. Based on that, your transaction class will be designed. So basically, if you are, for example, what they're trying to say is based on the different specification. For example, you are working on Ethernet, so there will be something called packets. So the how the packet structure should be there in the packet. How the for suppose some of the packets have some frame format like start bit, stop bit, all those now. So address, data. So acknowledgement will be between 0 and 1. Like some things will be there, right? So all those things you can just have your own type of constraints in the transaction class. So now let us see one of the simple memory verification I have taken up. So that we will see. So simple memory in the sense in that we will be writing the write data and the write address and read the address and read data just like that. So this is one of the transaction class, okay. So here in this memory, we have something called a control pin. This control pin is basically giving us a enable. Like if this is enable, we will do the write, and if this is not enable,
Hello.
then we will do the read like that. Yeah.
Like you're sharing something other screen, some other screen. Like we are. I mean, I am able to see that PDF only.
Okay. Wait. Maybe I haven't shared the entire screen. Now is it visible?
Yes.
Yeah. Thanks for telling at the beginning itself. Okay, so we have something called write enable right here. Means this is a control pin basically. When this is enabled, then only our write address and write data will be there. Otherwise, we will not perform any write operation like that. So these things are where I will get from the specification of that particular design. So every design will have some specification, right? So based on that, first you have to go through the specification. Now we have to do the APB protocol, right? So I will shortly share the APB specification also. So whenever you guys get time, just go through the APB specification thoroughly so that we will understand it easily. When I am taking one transaction class, what all the things, what all the attributes we need to take, that you will get all the information from the specification itself. Okay, so now we have the memory specification is like we have some control bit which is write enable. When write enable is high, then only this write operation will happen. Then only this write address and write data are valid basically. And then we have taken some temp data. So based on your requirement, what are the things you want to perform? Based on those, what all things you have to add, that you will add. So for example, here this temp data initially I wouldn't have assumed. So whatever things from the specification, I will just write initially, and then if there are something if I want to use in that particular driver or the anything or sequence, then I can come back and just add whatever attribute I need. So this temp data I have added that way only. So that's why I'm telling. Then we have something called reset. So basically, we need to, if you can see, you can ask me why is it these three are randomized, why this is not randomized. So seeing this, you can understand that this is an output. So the output means what the design will generate, right? So for the design, you will get the input through the driver. Means you will, for example, there is an adder. In the adder, will you also randomize the output also? If you randomize input also and output also, then what's the point of verifying anything, right? So there is no point of verifying anything. So what you will do when there is an adder, you will give A as 2 and B as 3. So it will these whatever inputs you are giving through the driver, no, those things will be gone to the design. So they will be applied on the design. So in design, whatever is there, you will have some logic, right? Inside the design, there is y is equal to A plus B. Right? So the Y will be evaluated by taking the inputs which we are giving from the driver. That is A and B. From the entire transaction, we will be giving those. So, so A value is 2 and B value is 3. So the Y will be 5. So if you randomize this Y also, then that will override the result which we are generating, right? So that's why we need not randomize the output value, and we should only randomize the input values. Okay. And then the constraint we have taken something like enable. Means the constraint you can give any name, but it's always recommended to give a meaningful name so that anyone come and see, they will understand, okay, this constraint is for this purpose. Okay, this is a reset, means this is something related to reset. So always I suggest my students to whatever name you are giving for the class or whatever name you are giving for the constraint, it should be something related to that particular constraint. So as soon as someone sees that, they will understand. And it's always recommended to give some comments, and it is always recommended to use some proper indentation. If you are working in an industry, all these things you feel like why very simple. But when there are so many complex things you are working, when you maintain this proper adequate like of writing the different codes and like writing the comments, maintaining the proper indentation, it will be easy for us to debug also. Okay, so let's not deviate. And so that we have some constraints here. So this is called the factory registration actually. So we will discuss this further. For now, we will just see like in transaction class what we'll be having. So these are the different transaction items we'll be having. So you can also observe that this transaction class is extended from the UVM sequence item. So just note it down like the transaction class should be extended from the base class called UVM sequence item. These things which we have to remember. There is no other option. So the more you will develop the test benches, the more you will work in the industry or any of the projects, you will be habituated. Initially, it will be little tough, but later on, because so many things are new to you, so it will be tough, but later on you guys will be used to it. Okay. So this is about the transaction class. Likewise, here we have taken different transaction class for write and read. So that's why we have only related write signals related to here. But this is very simple project, so we don't need to take like that. But here I had taken for just to explore like can we have different transaction classes? Can we have different agents? So to explore that, I have taken like this. So there will be one more read transaction class also. Yeah. So if you see here the read transaction class, here also we have read enable, the same thing, just that I have just replace the write with read, that's it. Rest all are same. So mostly you will understand this line, that is where we are extending. Even these things you will understand. This you know, right? If you want to randomize any variable, we have to write with a rand keyword. Okay, so these all things, and this is an output, so we are not randomizing. This is a constraint. So whenever we have randomized variables to get the control of that, that's why. So here what we have done in the enable, you have given like read enable as 1. So by default, always the constraint will be 1 until unless you override it through some your test case. You can't override this because here we haven't mentioned something like soft. If you want to override it, you can declare the same means the constraint with the same name. That way also you can override. Otherwise you have to declare here it as soft. Then you can override this particular constraint in your particular test case. Okay, these things you will not understand right now. So we will, and even this function new. So these things we will go through further. But other lines you should be able to understand. Okay, if you have any query related to these different lines, then we will discuss. If not, we will move to the driver.
The base class which you have specified as UVM sequence, is it like a default one or like a
Yeah,
kind of library existing
yeah.
something similar to that?
Yeah, it's a library. As yesterday we have already discussed, right? You in UVM we have in the UVM library we have different base classes. So whichever components which we have in our testbench architecture, which we want to use them, in order to use them, we need to extend from that particular appropriate specific base class. For transaction class, you need to extend it from the UVM sequence item only. That is only the base class for the transaction class. Likewise, for different components, we have different base classes available.
Okay, thank you.
Yeah. Now, so now this is the transaction item which is here to the sequence item. This is not a component. This is an object which is not under the hierarchy. This is in the outside the hierarchy. So these are this sequence and this transaction class. These two are the objects. Other than sequence and transaction class, rest all are the components. Just even remember these 2 points, like which is the component, which is the object. As there are only 2 things as an object, just remember what are objects. So other than those will be definitely the components itself, right? So that's it. That is it is. And next we will go through the driver. So far it is clear, right?
Yes.
So now the driver, a driver is also called as BFM by some people. So that's why I have just mentioned. So basically, someone if they ask you what is BFM, even though you know about driver, you might think that is something different. So driver is also called as BFM. Okay. So in driver is a basic what exactly the
Is
driver
there
will
any
have is
for that? BFM stands for, is there any abbreviation?
yeah bus functional model. Then if the driver is basically where the proper logic, like for example, in the APB protocol we have something like the setup phase or whatever. So all those things, whatever you want to send the particular things, right? If the setup phase, what should happen? Everything should be reset state. And then ideal phase, the first phase is ideal phase. In ideal phase, everything is zero, everything is reset. Then we have something called setup phase. In the setup phase, only some set of the signal has to be high. So that you will have to give the input, right, to the design. So this way, if they are there, then how the address and data are getting performed, that you have to observe. So that whatever things you will give, that is from the driver itself. So the driver basically converts the transaction items into the pin level activities, and that will be drive to the DUT. Okay, is it clear? Can anyone say what does the driver do?
Driver, it will take the sequence item from the sequence item through the sequencer, then it will drives the packets and send to the DUT for the DUT signal testing through interference.
Yes. So the DUT will send, the driver will convert the transaction into the pin level activity. So if anyone
Yes.
ask you what is driver, you can just say that the driver is responsible for converting the transaction items into the pin level activity, and it will send to the DUT, through which it will send it to the interface. Through interface, it will share it to the DUT, and the DUT, like how the adder we have discussed, right? So the entire logic is applied through the using those inputs, and it will provide the output to the monitor, and through the interface itself again. So then the monitor will capture the data in terms of the transactions. So whatever pin level activity we had given, right, that will be converted into the transaction items again when it is coming to the monitor. Okay, so this is the basic thing which you should be knowing related to the driver. You can just go through like what we have written over here. This will be just summary of what I have explained now. So we can say that the driver is driving the data, and the monitor is sampling the data from the DUT. Okay. So now we will see the code of the driver also in the RAM object. I have picked one very basic memory verification so that it will be easy for everyone to understand. If I take the complex one, first you have to understand the protocol, then you have to understand the driver, right? And I felt that it was tough to imagine the UVM concepts when I explained yesterday. That's why I've taken the simple code. So here, as we have already discussed, like the driver class has to be extended from the UVM driver. So that is what there in the line 1. Okay. And this is something called factory registration. This we will discuss. So right now you can ignore. And then what is the thing which we have to discuss in the driver is like what we have discussed, like we have to drive the data, right? So how are you driving the data? And what did I say? The driver has to send to the DUT through the interface. So this is nothing but our interface. So we have, you can ask me what is this virtual interface? So we need to understand that virtual interfaces also. So that also you can ignore for now. So now you first in this class you have to just observe that we have something called driver, which is extending from the base class UVM driver. The first thing. The second thing you have to observe is we are driving the inputs to the interface through to the DUT through the interface. So that is in this part of the code actually. In this part of the code is we are driving the data. This request dot is nothing but the transaction class is there, right? In this particular transaction class, we have the RAM retrans, right? So first, this is for write. So it's playing or what? The write transaction is there, right? So the same thing, we will be using it over here. Okay, if you are writing request means it will assume that it is a part of the transaction class itself. This by default is a request. So you can directly write request.reset, request.write enable, request.write address, and request.write data. Okay. So this will be, so the request.reset actually points to here. Here actually, from the write transaction. How will you say that it's from the write transaction only? Can anyone say from this entire part of the code? how will it point this value itself? Because we can have some other reset also, right?
Line number one.
Line number?
One.
Yeah. So here you are parameterizing, right? And you are passing the transaction. So through this, it will understand that this is belonging to this right transaction. Because I have here also the same signals. Here also I have reset. Here we don't have reset. But there could be a reason here also we may having the same signal name, for example. I have just address. I haven't mentioned anything read address. And even the right transaction also I have mentioned like that. So that how will you differentiate is to that. Okay. So that is related to the driver. Is it clear for everyone? So here what
Yes.
you have to observe is the first thing is that it is extending from the UVM driver, and the next thing is that we are driving the transaction things to the DUT through the interface. So these two things only you observe right now. So based on the number of classes you attend, the more idea you will get from the same file. If you see, you will have a different perspective after 5 to 6 days. But for now, you will able to understand only this line number one, and then this particular task. Okay. So now let's move to the other component. So we have sequencer. Sequencer we have already understood, right? The sequencer role is to just route the sequence items which are coming from the sequence to the driver. Okay. So this is very simple class you will be having for the sequencer. So here also I will be having write sequencer and read sequencer. So here, see, if you observe, there is only one, just we have something like sequencer, which has been given the right transaction and the end class. There is nothing over the sequencer we write over here. Just we will declare the sequencer. Okay. So there is just you have to understand that like the sequencer means it will just route the sequence items from the sequence to the driver. So this much understanding you can have. And then the monitor. So monitor is nothing but which I already told, right? Whatever the data the driver is driving to the DUT, it's providing the input. So the design will do all the analysis, whatever logic we have written. Based on that, it has to provide us the output, right? So those output which will be coming through the interface will be collected by the monitor. So the monitor is basically used to collect the data, means output which is given by the DUT that will be collected by the monitor, or you can tell that the monitor is sampling the data. The driver is driving the data and monitor is sampling the data. Okay, so this thing is about the monitor. So we can say that as someone asked, right, why we have only passive agent, why we have only monitor. There is something like a requirement. We have something like only master agent. We have something like master agent and slave agent. So master agent, for example, for the I2C, for suppose in the I2C, the master agent has so much to do. Like it has to send the start bit, it has to generate the clock, it has to send everything by the master itself. But the slave, it just need to give the acknowledgement, right? In that case, we are not driving anything, right? So that's why in such cases or in any of the cases where slave is just observing the data, it is just collecting the data, and there is no much things from the slave that has to be done. In that case, you can use a passive monitor, a passive agent, where you will have only the monitor, you will not have the driver sequencer and the sequence things. Because then there is no need why to have the all the components to get created. When there is need, then only we can have all those, right? That's why the agent, you should have the control of the configurability, whether it has to be operated as an active agent or it has to be operated as a passive agent. So this is all about the monitor. Basically, it is used to sample the data. So we'll also go through the monitor.
Hello, ma'am.
Yes.
I want to ask, like in SV, we are doing from generator, we are randomizing the data and sending to driver directly. So here
Yes.
also in sequence we are generating the data, and why we are using the sequencer in between, so we can directly give data to driver, right, from sequence. Like what is the use of a sequencer? Like that is extra
Basically,
component.
the extra component is that the methodology is like that. We have the sequence here. See, when you are sending from the generator to the driver, you are directly sending through some mailbox. Than mailbox, we have some more features with the driver and sequence handshake. Means like a driver, if you see, actually we haven't gone through that because now we will not understand. In our next session, we will be talking about the driver sequencer handshake. So in that,
Okay.
there is something like a blocking method at the driver side and the sequence side, some non-blocking method. All these are there. The sequencer will do the synchronization between the sequence and the driver. And it also has something like there are multiple sequences you have. So the sequencer has some arbitration process also, like based on the priority, whether it has to take which sequence it has to select. That also is possible
Hmm.
through the sequencer. So these
Okay,
are
okay.
some advanced concepts which are there in the UVM. That's why the sequencer has come into the picture. Uh,
Okay.
all those things are little advanced, so that we are not covering in this workshop. Like already yesterday, someone have asked, right? If you are not covering anything, just tell us so that we will refer it. So this is one of the things which we will not cover. There is something like what are the different types of arbitration methods used by the sequencer to select which sequence it has to be put to the driver, so that you guys can go through and make a note if you want. Okay, and then so now we were about to see the monitor code, right? Yeah. So here also the monitor is getting extended from the base class of UVM monitor, and then here if you see, so what was the idea from the monitor? It is like from the DUT, it is getting the output and it is collecting, basically it is sampling this data and it is providing in terms of the transaction, right? So from where it is collecting? From the interface. So this VIF is nothing but our interface. Here it is a virtual interface, so that also we have to go through why we are using virtual interface, why don't we use a simple interface. This also we will discuss in our next session. Okay, so through virtual interface, we are collecting the data and passing it to the transaction. So at the end, when we are coming to the monitor, after sampling the data which is there in the monitor is in terms of again the transaction itself, right? So if you see, that's why the task monitor is there, which you are writing in the run phase. So today we will discuss also the different phases we have. Then you will understand like what is this. Okay. So this is the what we have to understand from the monitor code. Nothing else I think you will understand. So if you see here the RAM write trans hedge. So if you are trying to declare this, but in the driver you need not do it, because in the driver you will be already having that driver sequencer handshake, right? It will be by default understand if you write the request here. Where is it? Right, driver. If you write just request dot, it will understand based on this whatever transaction you are passing, from that only it is getting, this will understand. But in the monitor you will not have that. That's why you have to declare that class ram write trans, and you will create the object for a transact. So now if you want to use any variables from the transaction class, you can just do transaction dot that particular variable, like transaction dot write enable, transaction dot write address, transaction dot write data. So whatever transaction items which we had, initially we would have given inputs over there, right? So now from the monitor, we will collect what are the outputs we have got into this particular transaction. Okay. So basically, this will have the same thing. And then if you see the read monitor, basically our output is a read monitor thing, right? So here the impact comes. Here you will be collecting you will collect all the information, but what is related to the output, that only you will send to the scoreboard. When this address, when this data is there, when write address is there, what is the write data? When read address and read enable is there, what is the read data? All those things will be compared in the scoreboard. So now the monitor has collected the data outputs from the DUT, right? So this will again send it to the different component, that is scoreboard. Scoreboard is nothing but where we verify our actual data and the expected data. Okay. So those things for the expected data, you will have already some logic where you will collect that data. and this actual data is from the RTL which we are getting it, right? So those things, both you need to compare. Then only you will understand now whether our design is working fine or not. Like for suppose now adder is there, y is equal to a plus b. So a value I am giving 2, b value I am giving 3. So y value will be 5. So I know the y is equal to a plus b. So I will write some logic related to, I will mimic the logic and I will give like this how it should work. So my expected data will be 5, I know. So from the monitor now it should collect the data from the DUT, right? So when it collects the data, it should give like y value as 5. So now I will compare my expected data and actual data in the scoreboard. I will write a logic in such a way. So then when it compare both, if it is equal, it means our design is working fine. If it is not equal, it means that our design has some bugs. So again, we need to debug from where the issue is coming. First, we need to see the log. Then we need to examine our waveforms. So based on the, are we missing any configuration? So this is very simple, like y is equal to a plus b in there, but nothing is that, but in real time, there is not so, right? So you have to understand, like, is from the configuration side, is there any problem? Or from the, any different things you have to examine based on the particular project you are working, you have to analyze and then come to a conclusion, why is it failing, okay? So this is about the monitor. And then we will go to the next part. So basically the agent. So now we all know, right? In the agent itself, we have the sequencers, driver and monitor. So all three are comprised inside an agent. So inside agent, whatever components are there, all those things we have studied so far. What exactly the transaction does and what exactly the driver does and what exactly the monitor does. So now before going forward, I would like to hear from any one of you what exactly the agent constitutes of. Let me call some name. Prajwal.
Some agent consists of sequencer, driver, monitor,
Okay.
and sequencer send the sequence item to the driver and it traces to the DUT through interface.
Yes.
And DUT throws the output to the monitor. Monitor sends output to the scoreboard, and it will be compared with the golden data.
Yeah. Yes. So now the transaction class will be extended from the which base class?
Sorry,
UVM transaction.
UVM
No.
subscriber.
I'm trying to learn new things then. Can anyone tell me the transaction class is been extended from which base class? We have
UVM
saw the
sequence.
code, right?
UVM
Sequence
sequence.
item.
Yes, correct. So just to correct your understanding, it's not UVM subscriber. UVM subscriber is for the coverage collector. So UVM sequence item, which is the base class to extend the transaction class. Okay. So, and for driver and monitor, it's easy to remember. And the UVM transaction is under the component or is under the object? Hello. Everyone is unmuting and everyone is waiting for someone else to tell. Any one of you tell.
The UVM driver is component, right?
UVM transaction?
And that is object.
Yeah. Okay. Fine. So we can move forward in that case. Everyone is on track. Okay, so the agent is what comprises of all these three components which we have gone through so far, right? So again, as we have already discussed, because someone has asked why we have active or passive agent. So it's always good to, in anything, like what will you prefer? If there is some television for you and if you have options to configure it, means if you have different options, you will like it, right? If it is something standardized, you will not prefer that. The one which has more options to be customized by you. So our generation always looks for the customization, right? So you want to make it either this way or this way. The single thing you want to use in the multi-purposes, basically. In the same way, here also the UVM agent, it is always recommended to make it configurable, like whether it should be in the from the env you should be able to control you want to have the active agent or you want to have the passive agent, because in most of the cases the same agent can be reused different projects, right? So in that case, if there is a configurability control with you, it is easy for us to reuse in the different requirements. So basically, so that is the main thing which you have to focus here. So here, if you see, I have written the same, like the some agents, for example, master or transmit agents. It has to initiate some transactions to the DUT. It has some functionality to do as such. But whereas some agents are like save or receive agents, they are just there to receive the data from the master. They have nothing to do from their side. In that case, we can use the passive monitor. A passive agent, basically. A passive agent means it will have only monitor. It will not have other components. Okay. So active agent means it will have driver, sequencer, and monitor, all these things. So this just have it in your mind, like what is active and passive, and how the agent has to be there, whether it has to be configurable or it has to be standard. So all these things, just have a look. Okay. So
In the
yeah.
PPT, under driver, you have mentioned it as an active entity, and under
Mhm.
monitor, you have mentioned it as a passive entity. So is it
Mhm.
similar like active agent and passive agent, or these are different active and passive entities?
Actually, they are trying to say monitor is passive entity because it is not driving anything, right? It is just collecting the data from the DUT. So that's why they are
Yes.
trying to make sure that it is a passive entity. In the
Okay.
driving active, so basically the main difference what I've explained between the active and passive also is also the same, right? In the active
Yes.
agent, if there is some requirement to initiate any transaction, you want to drive something, then you need the driver. That's why it is called as active agent. So in the passive agent, you don't have such requirement. That's why it is called as passive agent, because we have only the monitor component. So, but in
Oh,
active agent, you will have both the driver also and monitor also. So that's why
oh,
we have mentioned it is an active entity. This is a passive entity.
okay. Thank you.
Hello.
Good observation, by the way. Yeah.
Yeah, like a small doubt. Like
Mm-hmm.
as like previously asked, like our agent contains only one driver, one monitor, and one
Yeah.
sequencer. Right? Like, is
Yes.
there, yeah, is that the predefined rule that UVM tells, or like why we can't able to use say two drivers inside one agent?
That's why it is like within one driver only. Why you want to have two drivers means maybe you have some different things to do, right? So in that
Correct.
case, so in the same driver where you can implement, why to have two different drivers? That's a simple thing. That's it. Basically, you can say like it's a UVM. That's how it is standardized in that manner.
We can consider that as UVM rule.
Yeah, yeah.
Okay. Okay. Got it.
And yeah. So next we have something called, sorry, wait. Yeah. So environment. We will see the code of the agent, environment, and scoreboard at once. So let's understand what is environment. So this environment is nothing but a container which has all these different agents. So now, as we said, we can have multiple agents. So all these agents will be sitting inside the environment. Okay. So also, if we have something like coverage model, that will be also sitting inside the environment. And we have something called what is it, reference model, that will be also sitting inside the environment. So this environment is a basic container which encapsulates all these things. So that is only related to the environment. Okay, so there are, we can tell that we can have driver, sequencer, monitor, all these components, right? We can directly use them. Why do we need to put inside an agent? Or because if you do like that, it is tough to create all those things. If it is very what I can say, it is very useful in the case, like it will be very easy for us if we encapsulate all those components inside one agent. You can use that particular agent and you can reuse it, basically for the reuse purpose. So that's why that is encapsulated in an agent. And these all different agents which are there, that is encapsulated in the environment. This environment is there inside the test, and the test is there inside the static component called top, the test bench top. So this is how the hierarchy of the UVM test bench is there. So now we understood how the UVM hierarchy will be there, and we also understood what is the UVM test bench architecture. Inside test bench architecture, what are the different components we have, and each component purpose, what is for what. And then scoreboard also we have already discussed, right? Why do we need scoreboard and how do we use it? Like some test benches doesn't contain scoreboard. They will be doing something like self-checking test benches. Means in the same test case itself, they will write the comparison logic also. So that way also we can do instead of doing it in the scoreboard. So there are different ways. So having a specific scoreboard is always preferable because the comparison logic for it will be applying for all the particular test cases, right? You can use that scoreboard for all the different test cases of that particular IP, so it will be easy for us. If there is some test cases which you want to verify them very differently, or there is some other agenda, in that case you can have a self-checking TB also. So it is all up to the project requirement, or whatever way they have designed based on their architecture, they will prefer that. But here it's our duty is to understand what scoreboard does. So those things we have gone through. Okay. So now we will see the code of on the different scoreboard, environment, and agent. These three we haven't saw, so we will see those codes. And this is an architecture with multiple agents, so we can have different multiple agents also, right? In that, the first one was the basic architecture where we had only one agent, so we can have multiple agents. So this agent is nothing but we all know now, like what all will be there in the agent, like sequencer, driver, monitor. Okay, so now we will go to the code to observe how the agent looks like. So the agent will be extended from which base class? Can anyone tell?
UVM.
Sorry?
UVM agent.
Yeah. So the agent will be extended from the UVM agent. And so based on now, if we see, let me minimize this. And we will go to the basic architecture. Okay, so this coding is very simple, means just you will follow the architecture blindly, that's it, nothing new invention which we are doing. Okay, the architecture design was done, that is only more innovatively we have to think like this should be this way. Here it is very basic architecture, then that's why you might feel what is there in this, just one driver monitor, right? But if you go for the real-time industry project, we have different things, right? So how well you have made your different, how many interfaces are there, those many agents you will use, like that will be there now. So first I'm trying to tell you, like in this agent how the coding will be there, right? Means this agent is there. Inside agent, what all components we have? Monitor we have, driver we have, sequencer we have. So just we need to create those three. So like in this whatever is there, that we need to create, right? Then only we will be getting all those here. So that is the same thing which we are doing here. So in the build phase, and now again I am telling you this build phases we will discuss, but for now you just understand what we are trying to do. So whatever components are there, first you will declare them. So we will be already having the right monitor, driver, sequencer classes, right? All those you have to declare its objects here, and then you have to create whatever objects we have declared, no, that we have to create. So we have to understand this create method also, that also we'll go through further. So just now have an idea, like we will create these three components inside the agent. So with this idea, can anyone tell in ENV what we have to create? Let me minimize it. In ENV, what we have to create? In agent, inside agent, we have these three. So we have created monitor, driver, and sequencer. Inside ENV, what we need to create in that case?
Agent and scoreboard.
Agent and?
Scoreboard.
Yes. So it's very simple, right? Inside this block, whatever are there, those things we need to create inside that particular ENV or whatever is there, component. So now let us open the ENV file. See here in this particular architecture, basically what we have that will apply for to this project, right? So I had taken two agents there. So I had to create two agents, write agent and read agent, and one scoreboard. So those things I have to declare it and I have to create those things. And what is this connect phases? We need to connect, right? Here, if you see, there are some connections you are able to observe, right, between these two. Like, so all those connections, wherever inside this agent, this connection lies. Inside this agent, this connection lies. All those whatever connections are lying, those things you have to connect. And the driver sequencer is done by the inbuilt thing only. So you need not do anything related to driver sequencer. Rest all you have to be doing. Okay. So those things will be there. So here in the ENV, this is so the ENV has been extended from the UVM ENV base class, and then you will declare, and then you will do function new. Regarding this also we will go through in this today's session only. And then we are creating it and we are connecting it. So we have two agents, right? And the two agents inside agent, what is the connection is there is from the monitor to the scoreboard. Only those things is the connection, right? So in the ENV, we have only from the monitor to the scoreboard connection, which is lying in the ENV. So that is the only thing we will do. So we need to access that particular thing, right? So how you are accessing is through agent.monitor. This port. Inside this monitor, you have some port, you are connecting with the export. So this is again, you need to have the TLM modeling knowledge. That's why I'm not confusing you guys, but you just remember that now, like what we have gone through ENV, agent and scoreboard, right? So agent is how we have understood, like agent is a container which has all these three different components, right? So all those components you need to just declare it and then create it. If there are any connection between those components, those things you will do in the connect phase, and in build phase you will just create them. And then coming to ENV is basically also having some different components, right? Different blocks. In ENV container, we have two different blocks. Like one is agent and one is scoreboard. So these two you will be creating in the build phase, and then you will be connecting in the connect phase. So this much understanding if you have, that is enough for today. Okay. And now we will go through the scoreboard also. The scoreboard, as I said, will do the checking mechanism, right? So this is the checking mechanism. So to get the data inside this, we have some reference model here. So this is very simple memory, right? So you have very simple logic for the reference model. So when read transaction, read enable is there, then from the read address, you will, that particular address, whatever address it will get, that particular data it will have. And when from the address, you will have the write data. Like that, from the particular memory address, if you give, you will get the write data. Likewise, okay. So here what you have to understand is it has to be extended from the UVM scoreboard. And then what else you will understand? That's it. There is nothing here to understand for today, because all these are about the TLM modeling codes and all. This is the, we are trying to check the comparison, means whether your read data is not equal to 0, means there is some condition where we don't want to check, that we have written, then only, or we want to check those things when it is not 0 and when it is not X, means some invalid conditions if you eliminate. So rest all are the valid conditions only, right? So likewise, we have written something like that. And then we are trying to compare your actual data with the expected data. And if they both are matching, it's like success. If they are not matching, it's a mismatch, and I will give the error. Basically, here we are using $display, which actually we should, it's, if you have some some gadget with many features, more advanced feature, but still you are trying to use the basic feature, it is meaningless, right? It is just foolishness. So we should not use $display. Instead, we should be using some UVM info, whatever is it, because we can control those also. Like if you want to don't want to see that kind of displays, you can eliminate them. So there are some advanced features there in UVM. So in that case, better don't use $display in the UVM environment at least. Okay. So this is all about the scoreboard. So now let's go back to the slides. Now we have, so now it's clear for everyone, right? We have gone through each and every component and we have understood through the code. So the imagination is little easy for us for today. And we have understood some of the things, not the entire component we have learned, but whatever basic knowledge we have related to UVM, those things only we have understood in that particular code. So each and every day, the more concepts we learn, the more readable it will be, that particular code for you. Okay. So now let's go to the next part. So this is for the multiple agents, and then I have taken one more thing also. This I will explain later. This is little complex. Now it's not. It might not make that sense. When we go to the virtual sequence and sequencer, then we can go through this. I will keep a note that we have to cover this. Let's go to the basic things like the different UVM phases which we have. So now we understood like we have different components. So we also understood that we need to create the components and how the exactly the UVM flow has. Yesterday we had already discussed, right? The test is nothing but the root component which is there. But how will this get created? How it will start getting created here? So we already discussed there is some called static. We have the entire class based, right? Now we whatever we saw, scoreboard, driver, then agent, and then monitor. All these were based on class, right? But they are based on class or were they based on module?
Class. They are based on
Class.
class.
So this the entire class is a dynamic component world we can tell, and there will be however the dynamic components are not standalone. So we need to take one static component, right, which to make it standalone, which is a standalone to run this particular all this class based test bench. So we have something called top, that is our TB module, the test bench top. Inside that we have yesterday we had discussed, right, we have something called initial begin. Inside that we have some run test. When we execute this run test, basically the inside run test, we will be passing an argument of that particular test case name. So when we invoke this, then the actually part starts. All the components gets created. So when the run test is there, then the test is equal to new. This will create this other root component called test. Inside that env will get created. Inside that agent will get created. Inside the driver sequencer monitor will get created. Inside this one more agent is there, then that will get created. All this happens. So this is the basic flow of the UVM. How the exactly the different phases will trigger also, like when there is something in the test itself we have that, right? So to in order to start how the flow from the top to the bottom is like this. If anyone asks you what is the flow of it, you should be able to explain. Inside the top module we have something called one initial block. Inside that we have some run test. When this is invoked, then only our root component test gets created, and then inside test the env is get created, and inside env we have whatever components are there in that particular architecture, those will get created, and inside that agent whatever the components are there, those will get created. So this is the entire flow. If anyone asks you, you should be able to explain. When you know it practically in a pictured way, why I have taken this pictorial representation is now we will remember the UVM concept flow in this pictorial representation itself, and it will be there for more days if we learn something in the pictorial representation. That's why this is very important to for everyone to know, whoever know UVM. So just have a note of it. Okay. So now comes the UVM phases. So now we have gone through
I have a question.
Yes, please go ahead.
Well, so test class can be also dynamic, or it may be class it like driver or sequencer or environment. It will be always static.
No, it's a test class is class itself is a dynamic. When you say test class, it means a dynamic only. But we will also see the test file. Actually, good that you have asked that. We will open the test file. So where you will be having it is env, right? Outside env you will be having test. So inside test, what will be there? The env will also everything will get created, right? So that this is the base test, actually the RAM test. Here the env is sitting, right? This will be created. So the test is nothing but the dynamic component itself. So inside this test, what you will be having? You will be running the sequence onto the sequencer basically. So that will be there inside the test. Okay. So this is there, and now we will see the top module. We have reminded me in the right time. We will see the code of the top also. Okay, so see, this is the static module which we are discussing, right, in that flow. Inside that top, in what we have, like whatever UVM packages is there, that we have to import them. So then only you will be able to use all the UVM related features, right? So that's why we need to import the UVM package. This is RAM package, means inside this I have all my test sequence, whatever is there, no, those things I have included inside this package. So that's why I'm importing that also. And we have different macros, right? Like component, tick UVM component. These are all different macros. In order to use those macros, we need to include the UVM macros.svh. Okay. And then inside the top itself, we will be having our test, right? So the top will have what? That instantiated between the test and the DUT. So that like how in the Verilog we would do, right? In the test bench, our DUT is instantiated with that particular test. In the same way, we will be doing the instantiation. Here we will be connecting the signals through the interface. So the clock with the reset with the interface dot reset, write enable with the interface dot write enable. So all this will be done, and which was I was explaining, right? Now we have the clock generation will be there also in the top module, and if we want to do it something related to reset those things. So this is a basic thing, but in industry you might find differently. But the main things like the DUT instantiation, the package, all these things will be done in the even in the industry also we do the same way. Okay, this clock generation and reset generation that might be differed because we use some advanced things, right? This is very like bachu type, means a simple way of generating the clock. But this is a small project, right? That's why. In this initial begin and block, we have this config DB which we have to go through still. We don't know about this config DB so far. So what do you have to understand this run test, which we were discussing, right? Inside run test, we are passing the argument RAM even address test. So it means I am trying to exercise only the even addresses. I want the address to be given as only even address. So you can write some constraint in that particular, or you can write inside the sequence something like twice, and you can use that particular address. Okay, and then so basically that test will have that kind of logic. But here what we have to understand is inside run test we are providing the argument called this test. So if we are not providing here directly from whatever from the command line argument, you will have something called plus UVM test name, UVM underscore test name. Whatever argument you pass to that UVM test name will be overridden here. Okay, if nothing is provided over there, then it is like default. You know what is default mean, right? If nothing is there, that will get executed. In the same way, like in case statement, you have multiple statements. If nothing is entering into any of the loop, then the default statement will execute, right? In the same way, this run test also, if nothing is given at the parameter of the UVM underscore test name, there you will be having this RAM even, this test will get involved. Okay, otherwise if you are giving something from there, it will override whatever is given from the run test. So this is all about the test stop. So now we have gone through entire code actually. Like we have gone through the means different components also, test also, top also. Who is the one who have reminded me this question that thank you. I actually forgot to show. Now it will
Thank
be
you.
more, it makes sense to you guys, I guess, right? What we have saw in this pictorial representation, we have saw in the code also. Okay, so now we will go through this. No. Okay, so we have different phases. So like we have in the testbench architecture, there are different components, right? So each component has to synchronize with each other. So there are, in that case, these phases will come into the picture. So in the phases, we have three different kinds of phases. One is build phases, one is the runtime phases, and the cleanup phases. And the other thing which we have to remember is in the phases, there are two types of phases. One is time consuming phases and one is zero time simulation phases. So anyone know in Verilog what are time consuming and what are zero simulation? We know something like that, right? In Verilog or SystemVerilog.
So you mean tasks and functions?
Yes. So like that, even in the phases, some the build phases, some phases are there which are functions, means they will take a zero time simulation. The runtime phase is basic, the entire logics, whatever the test body, everything gets executed inside the runtime phase. So that is time consuming phase. So that's what is written here. The build phase is where the test bench is configured and constructed. So now we have seen the different code, right? In everywhere, in each component we have the build phase. So the inside build phase we have created something, right? So those things will be done in the build phase. In the runtime phase, I don't know whether you guys had observed the run phase or not, but still we will see it. In the driver, whatever logic we are driving the data, all those is there, right? Those will be executed in the run phase only. So these all will take time, right? So you are adding some delays also, everything. So only in the time consuming things you can add some delays. In the functions you cannot add the delays, right? It is not possible. So all those things come categorized under the runtime phases. And the cleanup phases are the end phases basically, where you will report, means the report things like whatever errors are there, all those report mechanism will be done in the cleanup phases. So this is all about the different phases. So now we will see in build phase what all different phases are there. In runtime phases, what all different phases are there, and cleanup what all different phases are there. We will go through that. And this is the I told now you have to know what is the flow, which I have explained in the pictorial representation. The same thing. We have just written in terms of lines like and this you guys I have told, right, from the command line argument, the UVM test name you have to provide the test if you want to. If you haven't provided anything, that will be the default which is passed in the run test argument, that will be there. If you haven't, if you have provided and you are giving the test, then it will be overridden. So just have a note of these things because this is little important because this from there only the execution starts. So this UVM is all everything is very interlinked. So if you know from starting to the end, it's good. Okay. So this is all about that. And then let's see, like as I mentioned, no, we have three different kinds of phases: build phases, run phases, cleanup phases. So build phase, we have something called build phase, connect phase, end of elaboration phase. So by now everyone would have known what is build phase, means where the components are constructed basically. And the connect phase is basically to connect, if suppose in the ENV, the agent to the monitor to the scoreboard was there, that connection is lying inside the ENV, right? So inside ENV, inside the connect phase only, you will do that particular connection. So if there is something called agent, and from there we have some connection, okay, that thing you will be doing inside the agent. Inside agent connect phase, you will be able to observe that. So if you want to see from where it is connected, you have to directly go to that particular component and observe the connect phase. Okay, through that you will understand, okay, this component is connected this way. Okay, likewise you will analysis. Okay, if some other project is given to you right now, so how you will understand what are the connections are there? First you will go to the architecture, fine. So again you will just have to go through the code, right? In that case you have to go to that particular build phase, or you have to go to that particular connect phase and have to see like how those things are connected. And then it comes the run phase. Basically we have inside run phase, again we have something like pre-reset, reset, post-reset, pre-configure, all this. All these phases mostly we don't use. Mostly we use build phase, connect phase, and then the end of elaboration phase is something if you want to see like report things, topology you want to print, all those things we can include in the end of elaboration phase. And then these phases also will be extended from the UVM phase, like that we'll have some function like syntax. I'll just show you all those. And then we have something like cleanup phases. Cleanup phases is basically, I told, right, that once everything is done at the end, what we do, like we will check the report, whatever reporting mechanism is there, final things we show. If you want to do something at the end, and then only after that you want to come out of the simulation, all those things you will be mentioning in the cleanup phases. But the most things you have to understand is mostly is build phase and connect phase. These are the main phases which everyone uses. So you should be knowing this. And one more important aspect with the phases is like you should know where each phase is working in what manner. Whether it is a top-down approach and which is a bottom-to-up approach. Okay. Can anyone say the build phase is a top-down approach or bottom-to-up approach?
Top down.
Yes, because when the root component is there, then only the other components will get created, right? So that's why the build phase is a top to down approach, and the connect phase is a bottom to top approach. So just go through like what each phase is of which kind of approach it is using, so that it will be easy for you. And the run phases are there, right? So all the components run phases will execute parallelly. And when it will come out of the run phase, that is also one of the big concepts. So that also we'll go through. But for now, you'll just have this in mind, like build phase means top to bottom, connect phase means bottom to top approach, and run phases means all the run phases of the different components will get execute parallelly. So this much knowledge you guys have now. Okay. So now, so what are the purpose of different phases? You just, whatever I have explained so far, that's the same thing. Like this is for the constructing and build phases here. It's not telling about the build phase. Actually, these are the build phase. These three things come under the build phase, says right. So, but again, inside build phase, we do only the construction. And the runtime phase, we do all the execution. And the cleanup phases, we do the like anything related to the coverage goals or anything, something which we are doing at the end. If you are trying to do anything report mechanism, or if you are trying to do something at the end, you want to compare anything at the end and you just come out of the loop, then all those things will be executed in the cleanup phases. Okay. So next comes the UVM factory. So once we will go through regarding the phases, like we have, see, in the ENV, we have build phase. In build phase, what we have done, we have just constructed, right? This using create method. And then the connect phase, what we have done, we have used. So now, I think build phase, connect phase, everyone would have observed. The what you wouldn't have observed is the run phase. That we will see. Inside run phase, if you see here, we have whatever sent to DUT, though we have taken the task here, this is called inside this only, right? Yeah, send to DUT inside the sequence item and sequence. This is one, the driver sequence a handshake. If you understand, then you will understand line number 16 and 18. So first, for now, you can see that whatever driving, whatever we have done, that is inside this. And you observe this. I forgot to, which is like in the build phase, the function void build phase and the UVM phase and phase end function. So the build phase is a function. But if you see the run phase is a task. So task is a time consuming. As I said, no, here this at the rate of interface clocking block, this is one delay. So all these delay things you can have it only inside the task, right? So the run phase is a task and all other phases are functions. So basically the questions on the phases will be like that. Like what are the different things are functions, and what are phases are functions, what is the single function which is not a function, sorry, what is the phase which is not a function and it is a task, and why is it task? All these questions might come. Actually, I have shared one interview handbook of UVM in the group. So when and where you get the concepts, you go through the interview questions there and then itself. So it will be easy for you to evaluate yourself how well you have understood. If you haven't understood, you just go through regarding those concepts. Okay. So main observation you have done, you have to write like super dot run phase of phase. Super keyword means you know, right? If you want to get the parent components, those if you want to refer, you use a super keyword. So for everything you have to use like that. For all the phases in the run phase, you have to use like super dot run phase of phase. This is a standard syntax. You just have to go to. There will be some means in the UVM library you will be having those phases functionality which you are trying to get and use it here, right? So you have to follow the same thing. Okay.
So I have a question.
Yeah.
So in a run phase, pre-main or main run parallel, or it will run one by one. After running a pre-main, then it go to main. In the
Yeah,
block.
after pre-main, then only it will go to main. If you are not using those phases in the run phase, then it will not impact. If you are using all the phases inside the run phase, like pre-main, post-main, so based on the like whatever pictorial representation we saw it here, right? So in this sequence only they will run. But
Okay, thank you.
different components pre-main phases will run parallelly again. So that will be there. So basically run phases will of different components run parallelly. But inside run phase, if you are using different phases, they will be running according to this sequence. Okay. So different run phase, what do I mean by is, for example, here the driver run phase is there. And then here monitor run phase is there. All this will be executing in the parallelly in the process in the background. So that's what I mean to say. Okay, and so this is what you have to observe regarding the phases. So regarding phases we are done.
Hello.
Uh,
So we can remember like I don't know whether I'm correct or not. So inside
Mhm.
every run phase, we have a driver, monitor, and sequencer. Those will be running parallelly, but inside them again the architecture like reset and all those things that will run sequentially. Am I correct?
Correct. So someone has asked like if it is build phase, if it is bottom up, what will happen? And see, I have already mentioned like the root component has to be created first now. Then only the other components will get created. When the run test is getting invoked, the component is getting created, right? If it was pointing to the driver or the sequencer, it is getting created, or the least component, the leaf node means you understand, right? The last component in that particular tree. If it is pointing to that, then it could be bottom to up. But when we are in the top module, when the run test is getting executed, it is pointing to the root component called test that is getting created. So that's why it is following the top to down approach. So when test is created, inside that we have ENV. We don't have ENV inside test. We don't have, right? We have test inside that ENV. So how our architecture is designed, the same way the UVM methodology also should work, right? Then only it makes sense. So if you create first my driver, it doesn't work, right? So that's why it is top to down, and it will not work like bottom to top. Okay. And then UVM factory. So now we said like we have different components and different. So is it okay to discuss UVM factory today, or shall I do it tomorrow? Is it overloading for you guys? It's up to you. There is only the basics if I will cover. If I cover also, I will not cover much. So you guys, it's on your decision. If you want, I will cover it today. Otherwise, we will cover it tomorrow.
I think you can start tomorrow.
Yeah,
Okay.
that will be
Fine.
better.
Also,
fine.
also you can share those codes. Maybe again, if you go through this video, it will be helpful for us. Like
Yeah, the recording will be there, right? The recording you can go through. The codes
okay,
cannot be shared actually, but when we work on the APB protocol, however, we will go through that, right? So you guys go through the recordings. That should be fine. The only the one who take the entire design course, no, for them, like whatever for workshops, we don't share the material to them. The course who take for them, we share the material also. But however, when we work on the APB code, that we will, however, everyone will work on their end, right? Then it will be fine. You will be having the copy of it, however. So for now, you can go through the recordings.
okay.
Yeah. Fine. Do anyone have any queries, or can we? Yeah.
Ma'am, I have a doubt.
Yes.
Can you tell me the difference between VIP and UVC?
So VIP and UVC. So UVC means what? What do you understand by UVC?
UVC is a universal verification component which will be written for the verification purpose in using UVM libraries. But whereas uh, VIP I don't have that much idea.
Okay. Basically, UVM verification component means, for example, some agent is there. Okay. So that UVC you are using means suppose there is an agent you have taken that particular UVC you have got it. There is because there will be very complex projects, right? For everything you can't keep on sit and write for that particular protocol. Also some protocols will be already verified and some people will be giving you that particular UVC. You can get that UVC and instantiate that UVC in your particular subsystem. In subsystem there will be n number of things, right? So though for those things you can get that UVC and just integrate that UVC inside it and you can use it. So your time will consumption or in working on the project will reduce. This is about UVC. The verification IP is yesterday I have already explained. For example, you want to verify your design. So what you can do is you can have one VIP and your design. How you will check like your design is working well or not? Like the design you can configure it as a master and the VIP you can configure it as a slave. And you can try sending the data from the master to the VIP and from VIP you can collect the data from the slave. And you can compare in the scoreboard like whatever data which is sending by the master and what is the data which is receiving by the slave are same or not. Okay. So all those things comparison we can so basically through VIP what we are trying to do is you are verifying your own design by with some VIP which is already been verified and you are trying to check the responses from the VIP based on your design and you can understand you will able to verify your design that way. So these are the two different things, VIP and UVC. Was I clear or it was confusing?
It's clear now.
Okay. Devika, you just ping me in WhatsApp. I will share you the interview handbook.
Sure, thank you.
Okay. And anyone else have any queries? How is it today's session? Is it fine? Is it understandable to everyone? Or are you missing? Are you able to follow?
Yes, I could able to follow.
Okay, what about others?
Yes.
Okay. Fine, guys. Let's meet tomorrow. Just go through all the things what we have gone through so far. Just revise. The more times you revise and more times you spend time in the initial stage, it will be more comfortable for you guys itself. Okay. So and just go through the interview handbook also. So far, whatever concepts we have covered, so cover those interview questions from that interview handbook and try to evaluate yourself how where are you standing, how many things you are able to answer and which you are unable to answer. Just go through like go through like what you have to understand, where you are lagging. So just evaluate it and just come back to me if you have any queries in the next session. Okay. Okay, then I'm ending the meeting for now. Thank you all.
Thank you.